icingaweb to our customers, and we failed. Only 5% of them used monitoring data on a regular basis, and 60% has never ever logged into icingaweb since registration. Surprisingly, all of them kept requesting monthly incident reports. Isn't it weird? Well, actually not. What you can see on the chart is the hit statistics of the intranet directory website of one of our customers. The company invested in some really useful productivity tools to help employees to communicate and solve common tasks faster. The dataset represents user activity before and after implementation of the automatic sign-on using Active Directory credentials. It turns out that if we ask a person for credentials, we reduce the usage of the non-essential services dramatically. There is a twofold decrease in intranet site usage in this case. But speaking of our monitoring data, how can we possibly restrict access without even using credentials? I have a story. 7 years ago, we made a decision to pivot from email notifications to some messenger because we believe that messengers are generally more suitable for quick delivery of concise, urgent pieces of information like monitoring alerts. And we've chosen Telegram based on the following factors. First, Telegram Messenger is the most popular in our region and is widely adopted by all our customers. Second, it has a free and well-documented API with the support of programmable bots. Third, existing API rate limits cover all our requirements now and in the foreseeable future. Last but not least, there were already plenty of solutions for Icinga notifications on GitHub. Yes, we are lazy. One of the biggest advantages of using messengers for notifications is the support of chat groups. Telegram API hides phone numbers of subscribers for privacy purposes. Instead, it assigns internal chat ID to deliver messages to distinct users. And in the same ID type applies to the chat groups. It means that your notification can be delivered to the group of subscribers with a single request from your monitoring backend. All you need to do is create a separate chat group on Telegram for every customer, project, department, and put the ID of this group to the notifications configuration block of the Icinga. So you can add or delete subscribers from chat groups using Messenger interface without even touching a single configuration. Now, if we take a closer look at this notification pattern, we will notice already solutions for a password-free monitoring frontend. Can't you see it? Okay. Icinga API can send targeted alerts, and Telegram Messenger will take care of the access control. If we could only find a way to make our notifications interactive. To solve this problem, we need to address the Telegram API. Formerly, to deliver notifications, I mean plain notifications, we made a one-way interaction with the RESTful API of the Messenger server. We used to run a simple bash script, sometimes Perl script, to perform a single HTTPS request which contained notification data and our private token to authorize in the simple JSON format. As we decided to build a sort of two-way interaction with the user, we will have to perform a regular polling to the Messenger backend for updates or receive webhook calls from the Messenger. Either way, we need to run a server application. And luckily, it's 2024, and we don't have to build an API interaction framework from scratch. Remember, we are lazy. And as there are a variety of open source, ready-to-go solutions, with help of Node.js and Telebot library, here comes the Icinga Telegram project. So under this QR code, we have a sandbox Telegram group with some sample monitoring metrics. It's open, feel free to join. If you happen to be a Telegram user, just scan it and you are good to go. First, you need to say start to the bot. It's a privacy measure of the messenger that prevents arbitrary bots from disturbing subscribers. So subscriber need to communicate with the bot beforehand. And after that, after sending a start command, you can request access to sample metrics with the sitrep command from the group. Be sure to send the sitrep command from the group and not from the private chat of the bot. We came up with this little tricky user interaction pattern. You see, we cannot allow our bot to post any interactive elements like buttons, like links to the chat group because it will create chaos and complete disorder because there are several users in the group and you cannot track the order of operations. Instead, we encourage a user to start communication with the bot from the chat group. Using this first request, we generate and store a session ID based on user ID and group ID, and send the user all the available links to a private chat, links to the metrics. And these links in the form of buttons will remain valid as long as session ID persists in the memory of our server. Yes, we cannot go stateless at the moment. We have no idea how to go stateless. As you can see, chat groups are doing a great job for access control. We can connect a group ID to a collection of Icinga services and treat every request originated from the specific group ID as authorized to access a predefined collection of metrics. And definition of these metrics are stored in the configuration of Icinga Telegram. I will talk about it later. Sure enough, normally these kind of chat groups are private and it's up to you to control the list of participants. Our test group is open, but it's not the real world example. And having unique links for each monitoring service might not be the most efficient approach, as your infrastructure is likely to comprise a lot of services, maybe hundreds and thousands. And frontenders say that the rule of thumb is to limit the amount of buttons to a maximum of 10 to feed the average device screen. To work around this discrepancy, we decided to introduce aggregation services to the Icinga configuration to combine the data on the side of Icinga and be prepared for the request of the front end. Here you can see a source code of the definition of one of the aggregation services, namely group list. This one generates concatenated text output of specific services for the given group. Service definitions are universal and should work well out of the box by default with no tweaks required. Just put them to your conf D and you are good to go. To use an aggregation service, define a group of hosts that you want to aggregate according to some filtration rules and apply to the service by simply adding the variable to it, like list services array in this case. Here we have a couple of config snippets that combine check results of services into one concatenated output. I personally find it convenient to make a dummy host with aggregation services for the project and use aggregation services from the distinct dummy hosts. And a side note, by default, the aggregation service always return OK status, ignoring all statuses of the listed services. This is done to avoid status propagation to the parent host and generation of unnecessary notifications. If you prefer the listed services of the aggregation to be propagated to the parent host like a dummy host, just uncomment blocks in the provided source code of the configuration, and it should work for you. Before the adoption of this solution, there are a couple security concerns to address. Icinga Telegram was written in JavaScript as Node.js Express server application. We did our best to reduce the amount of dependencies, but there are a number of minimally required NPM packages, providing network communication and API handling. I can't overemphasize the importance of dependency check upon the deployment. And as a concept, we use Telegram API for request authorization, which means that we rely on Telegram as a sort of security provider. Though it is unlikely for a major security breach on Telegram to occur unnoticed, it is a potential risk to be considered. Icinga Telegram is in beta version and available on GitHub. We have got basic installation manuals written. There are configuration examples and deployment pipelines for Jenkins that we use in our environment to bootstrap installation, but no system deinstallation script right now and no Docker image yet. We pledge to deliver the release version in August 24 with the following advancements. We want to move configuration to Icinga core to implement configuration download via Icinga API upon service startup. Yet it's unclear for me how to make it actually, and we are open for ideas. And that's why I deliberately omitted the configuration part in this talk. There is a local JSON configuration now, and we are planning to get rid of it. Also, we are preparing some interface improvements, like implement service grouping, like button folders for the services, and pagination, and implement interface language selection. I hope you find this session informative, and I look forward for your question and feedback. And by the way, we are looking for co-maintainers, as we have obviously underestimated the complexity of the project.